Expressions. What are they? Think of them as your yes or no questions. And typically, they evaluate to either true or false. So they either return a true value or Boolean, going back to the data types. These are your Booleans, which are true or false, or yes or no. So you can think of these expressions as like yes or no questions, or true or false like answers. Well, they return answers, is what I'm saying. But these just like are questions. So again, variables. 9 is going to A. Is A greater than 0? True. Is A less than 0? That's false. And then we have our two equal points, equal signs. This essentially means we're comparing the two values together, because we already have this one equal sign that tells you to set the value. So we don't want to confuse the two. This is saying, is A equal to 9? Which A is 9, so this is true. And this will be false, because A is not equal to 8. And then this is false, because A is equal to 9, and so on and so forth. Just this exclamation point, really important. Really important. It just indicates that it's not. You'll see that sometimes. And these two are pretty much identical to the less than or greater than, or less than or equal to, or greater than or equal to. It's just an extra equal sign. So yeah, those are those specific expressions. But there's other forms they can combine expressions together into using ands or ors. There's even like nots to negate the expression. Let's go over that real quick. So we have, let's just say A greater than 0 and A less than 5. So, what happens if both are true? Well, this entire expression evaluates to true. So great, what if one of our expressions is true, but the other one was false? Then it will be false. And why is that? So what and indicates is that both have to be true in order for the entire expression to be true. If one of them is false, or if both of them are false, it doesn't matter. It's the only thing it's looking for is that these two have to be true in order for you to return a true bool value, or in order for this expression to be a yes or an on or whatever. So let me just finish this out with just false, false. And you can probably expect what this is going to return. So that's explanation for our and. But then what about an or? What does an or do? If you put in an or like this. So let's just say we have one value that's true. The other is false. What will this return? Or what will this evaluate to? This will evaluate to true. And the reason for this is that the OR is only looking for if either one of these values are true. Or one of these expressions, I shouldn't say values, one of these expressions are true. It doesn't matter if both of them are true, it's just going to be true. But if both of them are false, on the other hand, then that's where it will evaluate to false, because none of them are true, or at least one of them has to be true in order for the entire expression to be true. Does that make sense? The next is our not. It's very simple. All that if this expression is true, then we just do the opposite of that expression, which is false. And if it was false, then it would be true. So that's a little explanation into expressions. I'm sure there's so much more you can do with them. Once you get into functions too, you'll realize you can return booleans, which then you can put into if statements. The reason I'm going over expressions, very useful for when you get into if statements and while loops, because they utilize these heavily. So yeah, that's expressions there. Now let's move on to what I've been talking about beforehand, which was if statements, and why they're very useful in expressions. So now we see here we're actually utilizing this expression here, or we have this word here, expression. That's just to say you can put in any expression here. What these if statements do is this expression has to be true in order for you to do whatever is inside these curly brackets right here. That's it. And if it was false, it'll just go back, move to the if else clause. And this else clause is here for, like, if you want to evaluate something, if it's false, just go to that else clause and do everything in those curly brackets there, is the whole idea. And the thing is, too, you can actually prove if this is true, of how if statements execute if an expression is true. You can easily just prove that by just putting in an actual Boolean value itself. Putting in a bool value. So try to, like, create an if statement, and instead of putting in, like, an actual expression that grabs a variable and compares it, just put in true. Just put in a raw Boolean value. And then just notice how this will always execute no matter what, because this will always be true. And then you can do the same for the, you can do the same for if it was false, actually. Where if it was false, this will never execute. Everything inside those curly brackets will never execute at all. So going back to here, if it was true, I just want to point out one other really important thing to note. Is that when this is true, yes, we know we do whatever is inside. But after that, we do what is after we execute everything inside. This will execute no matter if we evaluate whether this evaluates true or false. So if it was false, they'll just skip over to do this after. What I'm saying is, no matter what expression this evaluates true or false, no matter if this if statement is executed or not executed, whatever is after, outside the curly brackets there, will always be executed after. That's important to kind of note. Programs go in this sequential order. You kind of need to understand that.